Hello guys, my name is Yogesh. Welcome to our channel. Today we are going to discuss about matrix power function in NumPy. So first of all, let's understand how matrix power function works. So here I taking one matrix, given one example like m equal to 2002, number of rows equal to 2 and number of columns equal to 2. To do a matrix power function, there is one condition that it works on square matrix, means number of rows and number of columns should be equal. Then only matrix power function is possible. So how matrix power function works, like here m to the power 2 means it won't mean like every element is squared. If it is squared, it value is equal to 24004. Yes, we are getting the same result, but it's not the matter to calculate the matrix power function. What it will do, like it will multiply to the same matrix by using of matrix multiplication, what I have discussed earlier in my previous class. Like here I given one example how to do matrix multiplication. First row is multiply with first column, then only we can get a first element of it. So in this way matrix multiplication is done. So here 2 comma 2 cross 2 plus 0 cross 2. In this way second element will be generated, 2 into 0 plus 0 into 2. In this way we are getting 4004. So to use a matrix power function, first of all we have to import numpy as np. After that, what are the syntaxes used to calculate a matrix power? This is the syntax np.linalg dot matrix power, and a is the matrix where whom we want to do matrix power, and n is the power. Lineal represent the linear algebra because matrix comes into a linear algebra, so we have to im- import np.linalg.matrix power to calculate a matrix or power of a matrix. So what is n? Where n represent the power. If n equal to 0, give identity matrix. If n is greater than 0, repeated and multiplication means m square, m3, m4, m5 means m into m, m into m into m, in this way. If n is less than 0, then it will inverse and raise to the power. We will understand by using of example so that it will be clear easily, because it's not understood. I can understand that it's not understandable by using of this description. So we will do by using of practical application. So here we are taking a help function on np.linear.matrix power. Already I have discussed what syntax it is using. A comma n is the matrix, square matrix, and n is the power. So let's do one example and calculate a equals to np dot array. Here we are calculating. First of all, we are making one, sorry, my mistake. Okay, it's a 2D array, or we can say 2D matrix. Number of rows equal to 2 and number of columns equal to 2. It's a square matrix. And if you want to calculate power on it, np dot linl dot matrix underscore power. Okay, put a and we want to power 2. Here we are getting like 11, 14, 35, 46. This means it's not squaring each element, it is multiplying a into a. Here you can check multiplication of dot product a dot of a. Here you can check. I already discussed about the dot product matrix multiplication. Here you are getting the same result, np.linear.matrix power or a dot a. If we want to, like in this case, if we want to give value to the n, matrix power a same matrix. If we are giving 0, then it what will calculate? Okay, here you can say n equals to 0. That means it will not giving an error, it's giving an identity matrix of 2 cross 2. Why 2 cross 2? Because our matrix given matrix is 2 cross 2, so it's giving result as 2 cross 2 only. If we are giving a minus 1 value, let's see example. Okay, first of all, it will reverse the matrix. After that, it will power it to 1. So how to do reverse of matrix? We can calculate like A by using of np dot lin l dot inv of A. This is the reverse matrix, and power of 1 means same matrix we are getting. If we are do minus 2, what we are getting? This is the matrix, and power of this one is equal to result this. So in this way n is works in matrix power function. And what are the syntax used in matrix power function? It's a linear algebra property. So how to do matrix power function, it's very necessary to understand. That's all for today. Thank you very much. Stay safe and keep learning.